All right, welcome to our training. Thank you so much for joining us today. Um, as you can see at the beginning of this training here, we want this to be more interactive. So less webinar, much more sort of interactive training. So we will be enabling mics and cameras. So if you feel like showing your face, if you want to ask a question, feel free to do that. So we do want this to be much more interactive than like a typical webinar. We've all sat through too many webinars in the last 18 months or so. So let's, I welcome your feedback, your interactivity during this training session. And given that this is sort of a new format for us, please bear with us. If we have some technical difficulties or whatever, the demos don't work or whatever, we'll be kind of muddling through that again in a much more sort of interactive way. We are recording this session, but again, we want this to be more of an interactive training than me sitting up here talking or Adam talking, for the whole time. So we do have a set of exercises. I'll be dropping that link in to the chat. So feel free to clone this repository and follow along with all of the examples as we do them. So this link, there we go. Again, we will be heavily relying on our samples. We've got sample models, so model JSON that we'll be referring to as step 1 through 6, and then a final model. So if you're following along at home, please feel free to create models, import the models kind of at point in time, and we'll kind of mention that as we go through. Cash, where's the chat in this thing? Do we have a chat?
Yeah, it's just it should be on the right side of your screen, and then there's the chat, public chat.
Oh, there we go. Yep, got it. There we go. So clone that repository, and you can follow along in the example. The example that we'll be using is called Pizza Demo or Pizza Delivery. So you can click into Pizza Delivery. You can ignore the app templates and stuff. This is just the Pizza Delivery app. And within there, you can click the model directory on GitHub or navigate to the model directory, and you'll see steps 1 through 6, and then the final model. You will get a lot more out of this training, being that this is interactive and so forth. If you have an ONote account, and if you upgrade to ONote Essential, we have a promo code for the Avro PowerUp, which will allow you to use the Avro CodeGen feature for a month without paying for it. Cash will paste that in here in just a minute. But please do sign up for ONote, and Cash will give us that URL as well, the sign up URL. Upgrade your account to ONote Essential so you have access to schemas and Figma interfaces. And then you can apply the promo code that we'll give you, and then you can add the Avro PowerUp and not have to pay for the Avro CodeGen since you attended here. And do check out that example repository. We'll be leaning heavily on it. Or you can sort of follow along on GitHub if you want to just click around and browse the code on GitHub. That's fine as well. We're going to begin our training today. Kind of the first chunk of it, maybe a little less than half, will be Adam. He's going to be going through and sort of building out the model that we're using, the event model, sort of like he would do in an event modeling workshop. It'll be abbreviated, and this model is very small. We intentionally sort of wanted to take just really, really one slice of a model so that we could sort of build it out all the way down and give you that kind of experience. Most applications obviously will have a larger model, which is fine, but for now we just want to focus in on a really small model. There's the promo code, Training Avro. And so Adam will take the first little bit, kind of work through adding the events, adding the interfaces, adding commands, adding read models. I'll take over at that point once we have a more or less complete model flow, and I'll dig into sort of the data modeling. So that'll be the defining schemas using our new schema function in ONote, our schema feature. And I'll be building out event schemas and then command schemas and read model schemas. Once we have the model to sort of a complete state with all the schemas associated with all the nodes, then we'll generate some code, some Avro code. We'll generate some Java classes and interfaces from that Avro code. And then we'll kind of dig into, okay, what do we do with this code now? We have a sample application. It's just a very simple Micronaut application in Java. And we'll show you how to create a gRPC server in that Java application. And then we'll use a gRPC client from a different language, from Clojure, which is another JVM language. And we'll show the two kind of talking to each other. And then we'll talk about, how do we wire this all up to actually get a real implementation of this service using our events, our commands, our read models, and so forth. And in that process, I'll sort of tangentially touch on this UI implementation that we have. It's not all the way complete. It's sort of mostly useful at this point from the command line to act as a client for the server side web service. All right, so we'll turn the time over now to Adam. He's going to take us through our event modeling workshop, and then we'll take maybe a short break, and then I'll dive into the data modeling right after that. Go ahead, Adam.
All right, can everyone hear me? Just unmuting myself. Check 1, 2, 3. Awesome. Okay, great to see everyone here. It's a pleasure to continue to see the evolution of ONote, because as kind of the guy that came up with this approach, I've already hit the limitations of the tooling out there, Miro and all sorts of other drawing tools for collaboration. And I want to stress the fact that using a blank canvas, a drawing canvas, has advantages and disadvantages. We all know that being unencumbered by just being freeform is great, but I don't think we look at the lack of structure as a negativity enough to really show what's happening. So with some of the largest projects that we're doing, the event models have over 1,200, 1,500 steps. And the reality is, when you have a schematic that big, when you're using a canvas-based approach for drawing, even in today's browsers and tools, you end up hitting that performance on anything that's mainstream, even for development machines. I constantly have to run the canvas tooling in containers that basically limit CPU and memory usage. Some of them try to not load up everything, like images, at the same time, and other artifacts. So in other words, the canvas platform is quite heavy, and also having no guidance with what the structure is of an event model allows people to kind of not be guided and be a little bit too open, and then you start to lose the rhythm of the patterns that we want to follow in event modeling to get the cadence for development, to get the cadence for state transition, state views that we so love in event modeling. So ONote, at a particular crucial point in time, made a decision to make this more of a less canvas, but more of a positional kind of medium. And I think it's really important because there's a lot of opinion in the structure of an event model. There's the flow of time. There is the surface level API or UI layer that needs to always be on top. You have the source of truth of state that's always on the bottom. So you have these opinions already built in. And by allowing freeform, you lose that guidance. Much as if you're programming, I think this is a little bit more programming centric, this webinar. So just like your IDE can help you learn a language or a framework by autocorrecting things, etc., you can learn that particular paradigm or that language a lot quicker because the tool is built for it. and you'll get the feedback that there's things that are unnatural and that typing freeform text isn't going to get you anywhere. So in the same way, elaborating state transitions and the UI components and workflow components over time, and the storyboard-like aspect that we have in event modeling, with that guidance allows you to really have people jump in and get the guidance, so you don't have a huge ramp up, and that timeline between conceptual to actual running code on the server needs to be squeezed as tight as possible. And I think where we're going here is not the framework route, not the case tool route. What we're doing is by example specifications to enable what those tools wanted to do years ago. And I think this is the proper way to do it. And fast forward another few years, we're going to have AI really dig into very similar code within similar domains where we truly have automated 80, 90, in some cases 100% of the workflows. And that's our goal. There will be templates in this. So if you want to have the front load your workflow with registration and sign up and still have an ability to integrate custom features into it without really destroying that, you will be able to do that. Fast forward, more standard domain practices like inventory control. You should be able to plunk in an entire workflow that defines how an inventory service operates, how it exposes APIs, even how it has its own interface, and where you deploy that. So, this whole thing is really moving forward with kind of how AI will work anyway. It needs to be shown a bunch of examples of how things work. And event modeling is specification by example. So it's really in tandem with where the whole industry is going. And so as you'll see later on, I don't want to give any spoilers from Bobby's part here, but the end goal, it's a spike through to the end goal. So I hope you see that what we do with event modeling is really part of a much larger ambition to really help the entire industry, at least from the information systems. Like I definitely separate this from programming from information systems automation. I keep saying this because most of us are not sitting there making a new search algorithm. Most of us are doing day-to-day work in an insurance company or a bank or a point of sale system or whatever. You might be working at Uber and you're dealing with the same real infrastructure. You're just adding more workflows, more validation rules, more business rules for how what different ways can you change the state. And I think this is where we don't want to be stuck in the boring. We want the boring to be automated and really concentrate on what those outcomes are, what our users are going to see on their screens at the end of the workflow, and that they're satisfied that it worked. So I may be rambling a little bit, but I wanted to make that clear distinction because I wanted to really say why ONote feels different. And that's a good thing. ONote feels different because Bobby says that it feels more like a spreadsheet with cells, and that's exactly what it should feel like. The columns have a meaning. We are at a certain point in time. And as you're moving left to right, you're seeing what the system is doing, and you can interrogate that for that to really be an expression of contracts, data-like contracts, but really the workflow contracts from step A to step B. They're contracts on projections of how state is viewed by a specific aspect or page or step in the workflow. Those are very important levels of granularity that you can understand the system. And that granularity ends up being the building block for things that you commonly see in APIs, et cetera. And it touches into schemas, which you end up needing for large enterprises and scaling up projects. And, personally with, from our projects, like I said, some of them are well over 1,000 workflow steps. I need to break those up into specific different boards because the canvases just they can't handle that. And so what the goal here is to to have the right abstraction levels. So it's not just a freeform canvas eating up all your memory, etc. I would like these 1,200, 2,000 step workflows to be a real schematic, much like if you were to have a blueprint for a house. I keep using that as an example. Or if you have a schematic for a set of circuits that you would have if you have some sort of a electrical board, you might get a manual for it. In the back of those manuals, there's always this fold-out pages. I don't know if you remember, whenever used to, back in the 80s when I started computing, you kind of got the how the thing works in a reference manual, and at the back was on the back cover, if you open it, there was a folded over large page that maybe if it was folded over 4 or 5 times, it would fold out to quite a large schematic of showing you where all the chips are and how they're connected, if things go wrong, where to probe for 5 volts and ground and all these other things, so that you could replace a broken chip or other component yourself if you wanted to. And that's what we need for information systems. And so I want a large schematic that I can find everything on. And so this way of working with an event model is better, because I can fit everything I need into one schematic. So it's an easy, now it's a navigation tool. Now it's a design tool. You can use it, quote unquote, like an IDE. You can shrink regions or remove. This is versions 2.0 and later, but this is around the corner, where you want to say, I don't care about the payment aspect. I just care about the workflow. I know payment works, so I'm not going to be interested in how the payment gateway gets integrated into our solutions. I can minimize that swim lane, and the workflow will shrink to my scope that I want to concentrate on. And that's the way that we should be treating information systems. There's nothing technical about that. We should be exposing that to business. And so these tools need to really be the bridge between business and tech, and accessible from both. And so anyway, that's just my background on why I'm interested and why I'm backing this project, is because it has the right goals, it has the right spirit of where we need to go in the industry to bring people closer together. And a lot of that is the maturity of the tooling that allows that level of communication and that level of just load of information, because you have a lot of these endpoints, you have a lot of these permutations, a lot of scenarios you have to do. They have to be navigatable. You can't get away from them. Traditionally, we had to have them sprinkled all over different teams with different formats, etc. But we all know that coordination is a heavy price. So we want to reduce that cost. We want to have people. I think one of the companies that I'm working with has a great slogan for their push to get event modeling going and to have people collaborate. And they have that vision stated as better together, right? So remove the silos, have everyone working together. I think it's a really great slogan that they came up with, and they're I want to steal it. It's so good. Better together is wonderful. It's the opposite of silos, where we have artificial communication blocks under the guise of, well, that's my area of expertise. Don't interrupt me. I can be way more, productive or valuable if I do this alone. And that we've seen the negative impact of that. The answer is always you need some collaboration. So if we can have everyone using similar tooling, similar schematics, we're on the right path. All right, so on to let's see if I can share my screen. Haven't tested this yet. Where is the share screen button? Here it is. I found it. Start sharing screen. And I think it's this one. Yes, here we go. So let's see. Remember this decision. Oops, I can't do that. Firefox is very...
Adam, if you shared your screen, I can't see it quite yet.
It should be there now. Do you see it now?
Yeah, I see it.
All right. So here's that that timeline that canvas that we talked about. So in this, can everyone see my cursor moving left and right? So I'm moving specifically like I would in a spreadsheet. And that's one of the things that is best to bring to the kind of mindset when using ONote, is to think of a spreadsheet, that there are cells. We don't draw the borders sideways, but we do draw the swim lanes up and down. And we have that organization of our default audience, which is our screens. Usually we put that up here. We can put more default audience, so we can... oh, what am I doing? Hold on. Where is it? Add column. Well, maybe I can't. Where is my add interface? Nope, I don't want to add interface. I wanted to add, a lane below. Sorry. I by the way, I did not get to sleep until 4 a.m. because of work. So I'm a little bit slow today, trying to catch up on my caffeine. So if you see me overlook something, it's probably because I'm half awake. But I'll get through everything here. So, okay, so there's a default audience, and we want another audience, which would be the users. So let's see, delivery driver. So now we see that we have two swim lanes that we have. We can have a default audience, which could be random people on the internet or whatever as our default, but then maybe authenticated users that are here. Then we have the timeline, which is where your input and outputs go. Those are your, if you look at event modeling, that's your commands and views, state views or read models, the green boxes. So your blue and green boxes go in here. They're the middle of the whole thing that basically allows you to see what's going in and out of the system at any time. And then down here we have our actual services, which is really denoted by where source of truth of data or state is. So here's where our actual events go. And if we follow, the kind of workshop format that I suggest in my article, you first kind of brainstorm all the things that can happen. So, I ordered pizza. Oops. Cancel. So if I just hit enter here and I, ordered pizza, I can just do that, hit enter. I think I can hit enter again, or I think I can hit tab to go to the next one. And then at some point, pizza's delivered, right? Obviously, I'd have to pay for the pizza, a bunch of other things, but sometimes I like to bookend the two kind of, core events at the beginning of the workflow and at the end, and then just kind of fill in by walking dependencies, what comes in. Pizza delivered. If I hit tab, tab basically moves you to the next one. I'm just going to escape that. You can drag these around. So kind of like if you select the cell in your spreadsheet, you can move them around. You can move them to start organizing them to different swim lanes. So you can see that you have some of the canvas-like behavior, but you can see that it's also guided, right? So you can see that when, later on when you start to insert templates, etc., things will be inserted correctly. You're not, one of the, frustrations with the canvases is that you always have to shift click and drag a rectangle around an area. It's very manual, right? So here it's more like typing with a cursor where you can actually understand where things are going. And when they insert, that they're going to move these other things to the right, etc. So that's kind of step one. And I do have a pre-canned thing here. So, after we do this, we should end up with, orders and fulfillment. So you have order status updated. I probably would changed. Sorry, it's not displaying because my font size is wrong here. You have to double check the font size, but this one is order placed. This one here is changed, but it's not displaying because my font size, I think I have it cranked up for display purposes on this computer, but on yours it should look fine. Yeah, so that's where you should kind of be at the end of your brainstorming part. Like, hey, what events do we want? Again, this is not realistic. We don't have 2 events, but we want to keep it simple so we can get to the real good stuff of showing the mechanics of using these state transitions to do that. So, the next part that we need to do is add the command. So, the reason we do that is obviously to add places to validate, but also when we're doing pub sub to kind of show how a subscription can fail if there's no disk space on the subscriber side. A lot of people have a kind of, hey, you can't reject accepting of a subscription. And say, yes, I can. If I ran out of disk space, there's no way for me to understand and retain that fact that I received this information. So I always see the subscribe side of pub sub as having a command that actually does place the information in the subscription, the service that's subscribing. So if that makes sense, it's kind of out of scope for this session, but it's covered in a lot of my other talks. But Adam, it's fully supported here.
Adam, sorry, for my step 2, I did the storyboard bit with the interfaces. So rather than commands, I did interfaces next. So I think you've evolved on that since your article.
Oh, yeah, of course, yeah. So over here, if you insert, obviously because a timeline can have inputs or outputs, you have to make a decision. So if I hit enter and I say order pizza, notice I got a choice. Is it which way? I'm just using my, I want to type these things. So notice how I don't have to mouse around a lot as well. So the productivity on this is going to go up as you get used to this. You're going to be flying around with shortcuts, and you're going to be able to guide this a lot faster. So obviously that's a command. So I'm going to say new command, and I placed it in the wrong spot. Okay, so I'll move it over. That's great. And then you can see these little highlights here. I can join this, so I know that ordering pizza, the command, if successful in this example, it is successful. Therefore, it stores, that it's been successful. So we have that fact stored. That's great. And of course, to complete our cycle, I'm going to probably spoil some of Bobby's part here, but obviously, I have a list of my orders right now somewhere in the system, a projection of these. So if I hit enter and I go orders. I guess I can have a separate view for orders that are pending. Let's be very granular on this. And of course, oops, where did I go? Orders pending and read model. So that's green. And of course, that's going to listen to all of these different things. So I should have a, whoops, where's my link? Where's my link?
It's out of the top, Adam. Sorry.
Sorry, just take the top one as well?
Yeah, just drag.
Okay. Sorry. There we go. Okay, I saw another version. Okay, so I see all of these with different areas. So I'm still getting used to the improvements from version to version, but this is good. So one place, because they only go up. That's one of those things. Events can only link to the up. They can't link to other events here. So that's why this there's just this one here. So great. Anyway, and if we need to give ourselves more room, we can move stuff around. It pays attention to these things. If we have fulfillment, maybe it's the same one. Who knows? But you can see you got all of these. Ways to move stuff around. And of course, where does this command come from? Well, it comes from an interface. So let's see where we should be at on step 2. So, we should go into interfaces. So I skipped something, but yeah.
Yeah, that's my fault. I went to events and then interfaces like the storyboard.
Yeah, it doesn't matter. It's that's not no right way or wrong way to do it. I personally advise on what Bobby did. I was just trying to explain the tool more in this case. But yeah, the easiest way to start event modeling is say, hey, what screens do I have and what information do I store? And that's easiest to start with. So I myself add in the commands and read models later when I have a good idea of what all is out there. So Bobby is right. I'm just more focusing on the tool and what I like about it and what it's solving. So listen to Bobby; he's doing it right. I'm just playing around with the tool right here to show you. But the nice thing is that Figma integration is something that's going to allow you to drive the adoption of event modeling and everything that event modeling enables. Because I know that a lot of you have real interest in doing proper pub sub, supporting actor models, also doing domain driven design, all sorts of really good things that keep code organized and clean. And event modeling is a way to easily, without forcing your UI folks to read the blue book from Eric Evans to understand domain-driven design, you can say, hey, the Figma stuff you have, you can embed here. And they'll say, oh, cool. What is that stuff? Oh, that's what information is being captured as from the beautiful screens you designed. And we get to, see your beautiful screens right in our model. And they're like, oh, that's cool. Okay, so I see that you guys are running, 3 different services here for managing inventory, payment, and whatever else. And I now know how my beautiful designs are being put to work. So that allows that introduction to that side, which I really think is very important. And so we're from this UI part, we're going to see a lot more in event modeling, because it's such a unifying force all the way up to the executive level. We have those discussions. Well, show me the software, what it's going to do, how it's going to behave, what it looks like. They need to actually see what to measure the resulting system against. And this goes really far forward to have something that's not just a bunch of boxes and arrows on a whiteboard, which is like, okay, I believe you, but I sort of can't see proof, right? We need to have these tangible things for a lot of the people in our organizations that are, working with us. And so better together, back to that really awesome slogan. Yeah. This allows, the embedding of these things. So how would you do that?
One more thing, Adam.
Go for it.
Figma, we're huge fans of Figma, which is why we wanted to support Figma interfaces sort of right early on in our process. We're talking a lot about code generation today, because that's how you take a model that you've built in the style that Adam's describing and then actually turn that into a working service. Most of the code gen we're talking about today is back-end code gen. It's web service tier, write events down to an event log kind of stuff. But Figma opens up a whole world of code gen on the front end. Figma is all based on sort of an XML document. And there's really, really great plugins, many of them free and open source, for converting a Figma to code. So that, there's generating Flutter or Swift UI for mobile stuff. There's generating React components. There's some really great stuff out there in the Figma world.
Hey, guys, in regards to what you show here, my experience is that you lose the audience as soon as you introduce the commands and the read models. Is that a shared experience, or is that just my audience?
It's probably your audience, but you will have very different results with different groups. And after hundreds of these, that is a common thing. And that's why I said just a couple of minutes ago, a lot of times I start with just the events and just the screens, whichever they prefer. If they're brainstorming more about what should happen, they have no idea about the screens, I start with the events. If they're more visual and they say, we have to have a killer app that looks really good, and they want to see these screens on the app as they progress, the value, then I start with the screens. They themselves will start to later understand the read models in order to answer questions about when they really say, well, how is this UI going to be useful in these 3 steps? Is there one view that we can reuse and compose it out of 2? You can start to ask some of these organizational questions. You're not going to have just interrogation of all events all the time for every single different screen. So they're going to start to clump them together and like, okay, well, we have this view of, let's say, pizza orders. So we should have that. It's better to come at these green and blue boxes from the perspective of when they're needed. And at first, the blue boxes are redundant because they're just a yes or no. Does this actually, work? But then you start to dig into something maybe like password hashing, and you're like, well, the command is different than what's stored because you store the salt in the hash instead of the actual password. You can show that from a security perspective. The input, the command is to store a specific thing that the password you thought of and the actual keystrokes that you typed in that field, and then you had, and then you actually had the system store something entirely different. So those are places where blue boxes and green boxes will start to show their value. And if you start from an event model that doesn't have them, that you have to assume that there is a blue box for each of the events, and you're going to have to assume that for each screen that gathers some information, there's going to be a green box. And I would add them in later myself because I use them as an estimate, a way to estimate my effort, because I see a high correlation of the effort needed between the amount of different blue boxes and different green boxes. So I want those so I can actually track progress. Those are really good anchors for actually tracking progress and effort as you develop. It may not be apparent to business right away that that's what you're doing, but they capture the state transition and the state views, which are the building blocks of the complexity of your system. And it's the fairest way to guide yourself with how much time and effort you need to build the thing. So, if you get resistance to the blue and green boxes, don't push it. The need for them will arise naturally later. You don't need them right away. As long as you're capturing that the system is changing by capturing this information, and that what you're displaying is based on what you've captured, these green and blue boxes are implicitly there, but I would fill them out myself later. So I can delete these. If I'm doing something with the business, I can just leave the timeline as blank and just say, hey, does this make sense when I'm showing all of these screens in this order, and I show all this information being captured along the way? Does that make sense? And they'll either nod or they'll give you feedback on what's missing or why you're wrong or what should be changed, right? And once you stop arguing, then you have a solid understanding. You're in line, understanding the scope, the goals, everything from their perspective. You can now fill that in, because they'll ask you, all right, well, how long is it going to take? Well, at first blush, there's one blue box per type of event. So, there's one kind of count. And then the tricky part is, to display all those screens, how many different potential SQL, queries are going to run. If you're not doing event sourcing, if you're doing event sourcing, how many separate, read models are you going to have? And so, you have to kind of dig in. And of course, as a thumb in the air kind of an estimate, you start to look at the collections in each screen. And if they're different enough, you just assume that that's another green box. It's a little bit harder because the events are explicit. You can count them pretty easily, but a screen can hide some collections. So you have to kind of interrogate those screens, because they're not trivial. There's a lot of development that goes into making projections work right. And so you have to be careful to account for all the information you're going to look in those screens and then add those in. I hope that makes sense. It's a long answer to your question, but that's my way of dealing with different groups that are, have difficulty with one or more aspects of any type of exercise.
Yeah, no, makes a lot of sense. Thanks.
Yeah. All right. So yeah, we can add this. I think I have I have to move the size. So I think if I do the details again, designer, I think I can just crank up the size. Is this where I do it? Yes. Okay, good. Yeah, so then I think I can just zoom in. Yeah, here I can do the plus. Up. There. So now we can kind of see what's going on. Obviously, it's not an order list. I just used this random sample. I could probably make a proper Figma project, but obviously, if this is the read model that shows this, I can link that up, and you can see that that the orders pending. I should probably spell that right. And is something that populates this, even though I have the wrong screen here. But I just want to show you the mechanics. So,
so one more mechanic there, Adam.
Yep.
If you scroll up just a little ways,
mm-hmm.
Click the plus and minus button there in the lower right.
Yeah, that's what I was doing.
Yeah, that'll allow you to zoom. And then if you click the expand button in the upper right, you can actually expand and see.
Whoa, it's full screen.
Yeah, full screen.
I just went full screen. Yeah. But yeah, the key point here is that you have a very good bridge between another core team in your organization, especially if you're front end heavy. But even if you're not, there are internal screens for internal system apps that you need to kind of expand on and understand. So likewise, adding another command here, such as maybe cancel order. Oops, enter cancel. If I want to cancel an order from the screen, let's say there's a button on there. Obviously, I can go here and just grab this arrow and say, oops, what happened to my cancel order? Oops.
You forgot to hit enter and select command with your keyboard.
Oh, right, of course. Yeah, new command. Of course, we have to make a decision as to what we're writing here. And then, but there's another mechanic that Bobby's going to show you where you just, tab over to get this flow naturally. So, but and then we go again with if I go to cancel, order canceled if it's successful. And here I don't have to choose anything, and it's just linked up to that. And that's it. So was it Control Enter, Bobby? That
Shift Enter will give you the
Shift Enter will give me the next one, right?
The smart cursor. Yep.
The smart cursors. Yeah. So Shift Enter. Oops, that's giving me this.
Oh no, maybe it is Control Enter. Forgot my own keystrokes. Yeah, it is.
Why is my control? Oh, I see. I have it remapped on my. Nope. Come on, Control Enter, Shift Enter. Oh, Shift Enter goes into here.
Yeah, Shift Enter takes you to your details. So if you create a new, say, event, just start with a new event.
Mm-hmm. This one here. Oh, sorry. Yeah. I'll make it. Maybe if I'm in here.
Yeah, then hit Control Enter from there. Yeah, there you go.
Oh, okay. I see.
Type and then hit Control Enter again.
Okay, so test.
Yep.
Okay, it did it. Okay, yeah. So, sorry, I made a mess, and it's doing the next one here. Some API.
You can hit Escape now, Adam.
Enter. I just wanted to. But okay, so drawing the arrows out magically does work. Just so you know. You just have to learn the keystrokes. If you're just mousing around, which most people from the business side will be doing, they'll just be looking for these little arrows here to connect things. Yeah, so that hopefully gives you an idea that there is guidance here, and that
is it also Control Enter on the Mac?
I'm not sure if it is. It might be Command or Control. One of the two. Try both. See which
I
one
believe.
works.
I believe it is Control still. It is Control.
Okay.
They like to reserve Command for
Control
system
scroll wheel zooms in and out, so you can see Shift scroll wheel left and right, scroll wheel up and down. But more navigation's coming. This is the thing that I'm really, really excited about, because when using event modeling in Anger, taking it to the next level, you're really going to run into, hey, the reality of a large project is there's a lot of information moving around. There's a ton of things to coordinate. So you need that navigation, and this is a real blessing as soon as you see the amount of work put together, being able to get to the right places, be able to limit the scope of what you want to see, cut out parts of workflows. We haven't talked about the future. I had a really good chat with Bobby and the team about future features such as marking entire areas as workflow for onboarding, and then product research, and then purchasing, and then commenting and experience and sharing things on social media of what you bought, whatever it is, whatever workflows, whatever larger sort of epics, if you want to use agile tooling terminology, but it's about organization always. And so what we do is we always organize our really large projects into these rectangles of different workflows. And so as we get more mature with ONote, that is going to be a non-negotiable for large enterprises, which I'm really looking forward to. It's going to replace quite a lot of other tools for a much lower cost of managing such projects of such size. So I can't wait for those days to start. And anyway, but that's just from that perspective, which is a lot of value in itself. Now, over to Bobby for the other side, which is really actually kicking into high gear, getting all of the development to be much faster, much better guided, and really squeezing down the highest efficiency so that you're getting what you need to get done. You're not waiting around for too long, and if you're in a competitive market, you're not outpaced by your competition. So that's also incredibly exciting. So over to you, Bobby. Do I need to unshare my screen? Okay.
Yeah, I think you do. Yeah, there we go.
Did that work? Okay.
Yes, can you see my screen?
I have to refresh my page. I might have to drop off because my video is stuck. I think I had this with BigMarker once before. I'll try and give me a moment. I'll be back. You go ahead and start without me. I'll be back.
Can everyone see my screen okay?
Yeah, I think I see your screen.
Great. So this is sort of the step 4 of the model that Adam was building. He was sort of showing kind of the mechanics of how you build the model out. This is a model that I arrived at, right? It's not the perfect or the only event model to describe this flow, but this is sort of where we can pick up just so we have a consistent basis. If you're following along at home, this is step 4. So if you want to create a new event model here up in the upper left, you can add new. You can say, step 4. You can right click and then import event model JSON. And then you can either drag a file to this drop zone, or you can navigate to a particular JSON file from the repository and import it. So that's how you can follow along at home. You can make a separate model for each of these steps just to, if you're interested in following along. All right, so here we have our pizza delivery model. As Adam said, having these flows and being able to, visualize with your team, with the various stakeholders involved, visualizing how state changes over time is the most important aspect, the most business valuable aspect of any system. For users and business stakeholders, especially, being able to visualize, what is the user seeing and experiencing at each, point along this state change timeline is really critically essential. So we're excited about event modeling. We're really grateful to Adam for what he's invented and built, and what he continues to evangelize and spread through the community. A couple of things to make that event modeling process a little easier and smoother. If you're down here, and anywhere my cursor is, I can hit enter and I immediately go into sort of edit or renaming mode where I can name things. So if I'm down here along the bottom, anything south of the timeline is where events live. Anything north of the timeline is where interfaces live, and on the timeline is where our commands and read models live. So the first step that Adam talked about was sort of brainstorming the events. We actually have a brainstorm mode. So if you hit enter on your keyboard, type some stuff. If you just hit tab now instead of enter, that will create a new event and jump to the next place. So you can really quickly sort of brainstorm out these events almost again like a spreadsheet. And then when you're done, you hit enter, or you can hit escape. Looks like it made my arrows go crazy too. That's exciting. So yeah, that's how we can very quickly brainstorm out our events using just tab as sort of a brainstorming mode. We can dig into this model. Oh, there's Cash's face down at the bottom. We can dig into this model here in a minute, but I think we're at a good stopping point. If anyone needs to take a break, let's take about a 3-minute break. Grab a drink, refresh your coffee, go to the restroom, whatever you need to do, and then we'll come back. We'll do some data modeling, and then we'll generate the code and start digging into the implementation a little bit. So let's take a 3 to 5 minute break back here by about 12:55, 57.
Also, just as a quick heads up, if you're going to be watching the demo, the data modeling, we'll need the code gen feature for that as well.
So, Adam, while we're waiting, can I ask you a question?
Yes, absolutely. Sure. I am
Sure.
here.
Yeah. So what I've noticed is that for us it was really helpful to always start from the event when developing things, and always going back to reasoning from the event. So I was a little bit surprised when you said actually I take more the overall view and then from there start to discover or fill in the blanks.
Yeah,
Is
it
that too much
depends.
of a
It
approach?
really depends, again, on the teams.
Okay.
I do both.
Okay.
Yeah, the sort of canonical workshop format is that Adam describes in his article is start with the events. It's just brainstorm everything that happens and kind of reason from there. And then the second step is, roughly sort of chronologize, put all the events in a roughly chronological or causal order, and then put some interfaces along the top to get kind of that storyboard of, okay, here's what we're storing and here's what the user's seeing, and then wire the whole things up with commands and read models. Right, Adam, is that sort of resonate?
Yeah, I mean, it's really about the end goal is to have a schematic.
Yes.
And you start with where the least resistance is to get information out of people's heads onto the paper, onto the model. And in some cases where they have high importance on the UX, they're going to start with the screens. If it's a system that needs integrity and they need to understand the workflow, they're going to start with events, and that's fine. In the end, both sides are going to have the other aspects included. It's just really what is their, are you answering their top concerns and representing what's important to them as soon as possible, because then they'll see value in it, that what's important to them is represented as fast as possible, and that they have a role in the success of making this plan. And if you say, well, designer, you're just gonna have to wait until we're done with all the events, I kind of go, okay, well, why can't I do that first? Right.
Yeah.
So.
Yeah. The reason why I'm asking is because with UI, you already start with solutioning. And that's why I push back and say, hey, you should start with the events because we don't know the solution yet.
Yeah. I mean, to some people, a replacement for event is, I want to see this, I want a successful trade screen. And that is an event. It's that I saw that there was a successful trade, and I have a big problem with the dichotomy of problem solution space. I think there's a very large amount of gray area in between, and that if you're in the solution space or vice versa, you have to go to the other space to validate it, and so. It's my big pet peeve with a lot of the designing talks out there, that you're designing a screwdriver and you don't know that you need a screw yet. Yeah, that's kind of a tautology. It's an extremist way of representing this. I think it's a balance of the real world, and at all times we have to it's like clay. We're molding it until it takes the shape of what we want. So is molding something from clay a design, is it a problem or a solution space? You're shaping it with the knowledge of what you think you need at each time. I guess maybe the problem solution space really comes from the idea that we really built brittle systems before. It might actually come from even the time from before we did really good automated regression tests and had unit tests everywhere. And that once you went down one road, you were really stuck in a solution that no longer fit the problem. And it was like cement around your feet. And that's where this dichotomy is really bad. I don't see things with a proper design as having that one-way street and immobility. Because you know what you need to change and the impact of that. Yes, some of those may be costly, but they're not impossible, where I think the argument from solution problem space dichotomy came from. So I simply ignore it. I say, give me what's in your head. If in your head you're the person that's the loudest in the room and actually signs the checks, and you already came up with a solution, so be it. Maybe if you build it quick enough, it can fail and you can start again.
Yeah, and that's really the key, I think, to solve that dichotomy of problem space solution space is a fast feedback, right? Your example of clay is exactly right, because when I'm an artist and I'm working in some medium, I'm in problem and solution space all the time, because I see the problem, I see, where I want to get, and I make some sort of change, and then I evaluate my change, and then I make another change and I evaluate my change. So that jumping back and forth between problem and solution happens almost instantaneously, rather than being these two discrete things that are separated by months or years or some audit or some business thing or whatever. Yeah, so
exactly. And just to add to your point, Bobby, I always say that if I want to explore a problem space, I'm going to throw a bunch of solutions at it and see which one makes the most sense. Because I could have like real kind of spikes of functionality to poke the problem space with, knowing that I can remove them or change them really quickly, like you said.
Exactly. And if you have a good, design that is flexible enough to allow you to try a bunch of different implementations, that's, at the end of the day, the market is really the arbiter of what works and what doesn't, right? So when you're in lean startup mode, you do that. You go through all these, tons of solutions to try to poke around the periphery of what the actual problem is that we want our users.
I think the key point is that the problem solution space is kind of this it's kind of used as FUD, that if you have something that works for you to quickly iterate, that you're going to get stuck in a solution. And I don't think that's the case. I think especially if you're for us, the magic happens when we're doing event sourcing with event modeling, because we know that to capture some information when you have something happening, whether that comes from a screen or an API or whatever, that is something that you can use for the time being, but you can, version it or abandon it and start using a different abstraction. We have an account in the actual, even live systems of what happened. And simply because we're doing that combination, we don't have the large data migration problems that, like you said, sometimes those solutions are immovable. The last company I worked at before I started this, we couldn't migrate users from the version that they were using to the next version. The data migration was a nightmare. It was faster to backport features so that they were stuck on version 3.2. Everyone else was installing 3.3, but they could only do 3.2.1 or something, which the 0.1 included the features for 3.3. That was easier than the actual migration. So I know where all this comes from.
And that actually segues nicely into kind of taking just the slice of this model. Really, as long as you get, the rough vocabulary of your events right and, validated by your business, everything else can change. The UI can change, how the user introduces change into the system can change, how you aggregate the data up to show your user what's going on can change, right? Like, we're not married to any database schema or any database technology or any, front-end UI technology, right? As long as we have that log of events, that's really the ground truth of the business. So that's the thing that you don't want to change very often, but really, there's a lot of degrees of freedom in these systems that allow you to be really flexible. And to that point, kind of going back to our model here, this pizza delivery model, we've got this order placed event that forms sort of the beginning of this slice. And where does that come from? I don't know. It's not my problem, right? Because in a lot of companies, in a lot of contexts, the team that's responsible for making just the pizza delivery tracker app, or maybe the back-end fulfillment service, that allows that tracker app to see where the pizza is in the fulfillment process, they may not be the same team that's responsible for the mobile app and the ordering experience and the product catalog and the accounting and the orders and the line items and all that stuff, right? So different teams, different digital experiences. All I know is that I get this order placed event and it shows up, on a stream or on a queue or something someplace. Like, that's my initiating event, is when an order lands. Now we're in my world. So by having event modeling, it creates these really, really firm contracts around particular slices. So my world begins when an order is placed, and it ends when we we change the status of that order, and then at some point we actually don't have this here yet, but at some point the order status changes to delivered or whatever, and that's the termination event. Like once the order is delivered, I don't care about tracking it anymore, and we can remove it from our read models and so forth. So we've got this really narrow slice of functionality that we're sort of zoomed in on here. We've really got two audiences that we're talking about. We're talking about customers who want to just track the status of their order. That's really just a read model thing. I just want to see, where's my pizza at? And then you've got the fulfillment team who is introducing change into the system because they're the ones doing stuff in real life and then tracking that work using our information system. So that's the team who's, receiving the order in their order system here in their fulfillment system. They're accepting that order. They're preparing it. They're sticking it in the oven. They're putting it in the driver's car, and then driver's taking it, dropping it off at the door. So that fulfillment team includes drivers and some other people. And maybe in a future version of this model, we want to separate out the person making the pizza from the person driving the delivery vehicle, from maybe a manager who checks and expedites the order and makes sure that everything looks good and all that. So, this gives us lots of room to iterate on this, but really the fundamental events are the same, right? We've got an order, and then that order's status changes, some number of times as it works through this process, and then eventually it is delivered. So that's sort of the crux of this model. There's only a few things here to sort of track. When you're at this level where you're, doing what Adam just did, and you're brainstorming and trying to figure out, what is this problem that we're solving? What are the events? How does the data flow through the system, et cetera? That's sort of the event modeling process. You're probably doing that with business stakeholders and maybe your UI UX team, helping you with the Figma stuff. And right, there's a lot of stakeholders involved here, and you're staying high level. This canvas that we've created in ONote is not a graphics editor or a drawing tool like many Draw.io or Miro or whatever. But it is graphical, right? And there's a really graphical element to it. You see these arrows, you see the colors, you see the Figma embeds and so forth. Yeah, so Michael, we do have some features coming up that is sort of a bird's eye to help us navigate. Adam talked about this a little bit. We can carve up a really big model into workflows. That's not available yet. We do hope to release that sometime in the next, infinity months. Can't promise anything on our roadmap, but yeah, we do have the idea of being able to sort of jump to a specific slice or specific workflow within a much bigger model, and being able to navigate among them. So here we've got this particular slice, and while you're working with your business stakeholders and your graphic UI UX folks, this is probably the right level of granularity, kind of everything you see here. But in our tool, off to the left here, you've got some more stuff. So if you click this, the menu stays expanded. Otherwise, anytime you hover over it, it expands. So over here, there's some more stuff. We can manage schemas. We'll talk about that here in a second. You can actually export this model and then move it to another computer or check it into Git or whatever. You can generate Avro, which we'll talk about here at the end. So there's a lot of stuff here on the left-hand menu that allows you to get more out of this model. Most business users and graphic designers probably won't care about the stuff on the left. Additionally, if I right-click and hit Details, or if I just Shift-Enter, where my cursor is over a node, now we have a drill-in view where we actually see a lot more information about this thing. So we can actually name this thing, change its name. We can give it a markdown description, and we can save it. We can see, a description here, which is useful for documentation purposes and discussing what this command really is, or this read model in this case. But there's also this schemas tab here, which allows us to associate a schema to a particular node. So here we've got a lot deeper information. You saw this before with, oops, crashed my view. You saw this before when Adam dug into the interface designer. You can see the details here from a name and description perspective, but you can also see the interface designer, which allows me to resize things, change the Figma URL. I can even change to a different interface type and then build my own by dragging HTML components around the screen and so forth. So this deeper view, this is probably going to be used mostly by the implementing team, the team who's really responsible for delivering this service. They're the ones who are going to really dig down into the nitty-gritty of this model and define things all the way down. The most important aspect of this model that isn't the graphical sort of layout event modeling part of it is certainly the schemas. That's the data model associated with the flows that the graphics describe. So here at the top level, I can manage schemas, and this allows me to see kind of all the schemas in the event model. If there's some common types that you're going to use over and over again, maybe some enums or something, you can add those here at the top level, and then those will be available to be associated with a particular node or to be referenced from within another schema. So here we can say, I don't know, let's give it a order type enum, or no, let's say order status, because that's what we care about here. Example pizza. So here we can define this schema as an enumeration type. So we can say this is an enum. We don't have any symbols in this enum yet, so let's say preparing, and maybe en route, or maybe in oven. That's a good one. In oven, route, so it's in the vehicle, and then delivered. So now I've got a handful of symbols here associated with this enum. I can save it, and I can validate data against this enum. We can say, you know, good. So preparing is one of the symbols in the enum, but preparee is not. So I can validate sample data right here and get a sense for maybe we have some, you know, orders laying around, and we can grab the JSON from our database or whatever, and we can validate, hey, do we have the right schema? You know, we can sort of iterate on the schema here. So I've created an enum. The other one I just mentioned is maybe order. Here we can say, okay, what is an order? Well, an order is like a record. It's got, you know, named fields. So let's say, you know, it's got an ID. That's probably, I don't know, a UUID. And this is where maybe we'd work with our business stakeholders to really drill down, like, what information are we getting from our upstream system, and how do we spec that out? We can add another entry and say, maybe there's a set of line items in an order. This is a little more complex here. This isn't just a scalar type. This is actually going to be maybe a sequence. A sequence of what? Well, it's a sequence of further maps. So now we can say, okay, what is a line item? A line item is, I don't know, an item ID. Maybe that's also a UUID. Maybe there's a quantity, like how many of these things do we have? That's probably like an integer. Maybe we have a price. We're not going to store that as a float. Never store money as float. That's an integer number of cents. So we can, you know, save that schema. Okay, now we've got a map, which is defined as an ID, an order ID of some kind, and then a sequence of line items. And each element of that sequence is a map.
Tell that to the crypto world about the cents.
No, never store anything as floats. Floats
I
are bad. So now we can, you know, we can start to validate data against this. Okay, let's see. We have an ID, and it's 1, 2, 3, 4. Oh, that's not good because it's not a UUID, right? So we can paste in data here to validate against the schema we've defined. So we get, again, that really fast feedback of, here, I've defined something. Now let me like play with it and test it out a little bit. Very soon, we will also have the ability to generate sample data from these schemas. So we can say, hey, just show me, you know, 5 of these things. Generate me a sample of 5 of these things, and then I can validate them and make sure that they look okay. So that's how I can define schemas at the top level. Now, when I have, I navigate back here to my kind of canvas. Now I want to associate schemas with a particular node. So I can say, let's take our order placed event, jump into that details view again. And now we can associate a schema with that event. So the schema role, let's just say this is the default entity schema. For events, you really only need one schema, right? It's just that's what this is. The event is this thing. We can select an existing schema here, or we can define a new schema as you just saw me do. But since we already have order, let's just call this an order event. So the order placed event comes in, and the data associated with that order placed event is our order schema, which we defined at the top level. If I go back and I say, oh yeah, I forgot something really important. On our order, we need to have an order status. Great. So we can say, let's add a map entry, call it status. And I've already defined order status as an enum, so I don't need to define another enum here. I can just say, here, let's reference another schema. And then this will allow me to select schemas I've already defined. So here we're referencing the order status enum so that we can reuse that in different events and requests, or commands and read models across our model here. So that's how we define a schema for a particular map. And now if we go back to, or sorry, that's at the top level. We're defining the top level order schema. If we go back here to our order placed event and click at schema, we see that that change has reflected here. So now we have status as a part of our event schema. Any questions on that so far, defining an event schema? All right, if you don't ask questions, I'm going to keep going fast. So now, events, as I said, really only need one schema. When we talk about an event, we're really just describing what data is persisted by this event. What is the event that we store on our Kafka topic or in Event Store DB or in Redis streams or wherever we're storing these events? What are they? What is the data? When we're talking about commands and read models, we're actually really describing a communication protocol, right? Most of the time, the commands and read models in your system are going to be defined or rather implemented by your web services tier, right? That's going to be the thing that takes in a command from the user, as in this arrow here, right? From this order in process thing, I've got a button down here at the bottom that says, accept this order. That's going to put this order in my queue and change its status to preparing. When I click that button, I'm sending a change order status command. So when we say, okay, let's define a schema here for this command, let's add a schema. And in this case, we're not defining just a default entity schema. We're really defining a request schema. The request schema for the command is actually the command that is sent from the user. We'll also want to define a response schema, which could be as simple as a Boolean saying like, yep, we did it, or nope, sorry, something went wrong, or whatever. We can also define an error schema, so if something goes wrong, we can parse those errors back out. In this case, we're going to define the Avro request. Here, we're going to define a new schema, and we can, I'm going to cheat, I'm going to look at the schemas as they're already defined. So this order status changed event, let's call it order status changed, or we can maybe even say like, mark order, that's the command, is mark order as in the oven or whatever. Example pizza. And now we can say, okay, what is this? Well, it's also probably a map. What are its keys? Well, we need to identify what order we're talking about. So we're going to have an order ID. It's going to be our UUID, as we said before. It's our way of uniquely identifying an order. And then we need a status that we want to change this to. So we'll say order status. And again, here we already have our reference to order status. So now we can reuse that order status enum that we defined at the top level. So now we have a map that is just a simple thing here. It's an order ID and an order status. So let's try this. I've got a JSON blob here. Paste that in. Oh, that doesn't look right. Okay, let's change this to order status. Okay, that looks pretty good. And then, oh, this actually isn't a UUID because we're parsing it. If I change this to Eden, actually make this an order ID. Great. So I can play around with this a little bit, validate that this works. I see this valid checkbox down here saying, okay, good. This map of order ID to a UUID and order status to one of my enum symbols, that validates. Good. So that's the request schema. What about a response schema? So again, given that a command really is an exchange of messages, the UI says, do this thing for me, please. That's the command. That's the request. And then the whatever's handling that your command handler is going to say, yes, we successfully did the thing you asked us to do. Or, sorry, what you're asking me to do is invalid for whatever reason. Or we couldn't, or the service was down, or whatever. So there really is this sort of exchange of messages. So here, let's say Avro response. Let's just define a schema. It's going to be very simple. Let's say mark order response, example pizza. And we'll just say this is a Boolean, right? Thumbs up if it succeeded, thumbs down if it didn't. Good. So that's how we define the schemas for a command. The opposite, the inverse is true for read models. So if we jump into the read model schema here, we can see, okay, we need to add a schema. The request here is actually the question that the user is asking, the query. Show me the orders to fulfill subject to these parameters. Maybe I just want to see one of the orders and I'm going to look it up by ID. Or maybe I just want to see the ones for a particular customer ID. Or maybe I just want to see the ones that I'm working on, right? The fulfillment, my employee ID is associated with or whatever. So this is the question that we're asking. Right now, I don't really care or have time to go into it. So let's just say, orders to fulfill query, something like that. And we can just say this is a map, but I'm not going to define any keys in this to save time. So we just got a map. So anything that's a map, we'll pass this this schema. We can validate that. Yep, that's valid. And so is that. Great. So that's the question when I'm talking about a request. As it pertains to a read model, that's the question that the user is asking. Show me this data subject to these parameters. The response is really the read model itself. So let's define the Avro response. And really what we have here is some set of orders that I'm going to respond to. Maybe there's also some pagination information or something in there as well. So I can say orders to fulfill example pizza, and I can say, yeah, let's define this as a map. The most important map key is obviously the orders. Like this is what I want to see, and that is a sequence. So that's going to be like a list of orders. And what is an order? Let's say reference to another schema, and we'll grab this order schema that we've already defined at the top level. So this is now. The response that I'm getting back is a map that has this orders key, and this orders key is what stores the list or whatever of orders. So that's the important bit there with this schema. Maybe in the future we're going to add pagination to this, and so there'll be like a offset and a limit and a few other things so that we can allow the calling UI to page through a whole bunch of orders or something like that. But for now, we know that we just want these orders in there. Okay, so now for this read model, we have a request and a response defined. One more key aspect of an event model, and especially an ONode event model, is that the definition of a command event read model interface is separate from its placement on the canvas. So if I select this here, I can either use Control C, my keystrokes, or if I just copy this, I can paste this further down on the canvas as I did here in this orders to fulfill. So you see the same read model here. That's not just two different green cards that I added. That's the same green card placed twice. I copied and pasted the first one. So when I check the details here, schemas and other details associated with the read model are a part of that read model. And that read model can be placed via placements several different places along the canvas. This allows a high degree of reuse, and it allows us to do some really sophisticated analysis about, okay, what events are feeding a particular read model over time. So this order placed event is obviously feeding it. This order status changed event is obviously feeding it. So we can do some analysis. We don't have this feature yet, but in the future, when we're sort of generating some event processing level code, we can see, okay, here's the 5 types of events that get incorporated into this read model somehow. We'll leave the code of how it gets incorporated as an exercise to the implementing team, but at least we know, like, here's the schemas that get fed into the transducer that builds this read model. So here again, if I check this, the schema is defined for every placement of this read model definition. Good so far? Any questions on events, commands, or read model schemas? If not, we'll get to the exciting part. Oh, go ahead, Anders.
Yeah. Or somebody else first?
I just
Okay.
want to say it seems great.
I've got a little bit more of a question. What if the read model is used by automation? So it's actually more my state model. How is that going to work?
Same sort of way. There's some way that your automation is getting that read model and then perceiving that. So if there are parameters associated with getting that, maybe it's not across a web services boundary, and that's fine. In that case, you probably could just define the entity schema for that model. Say, okay, here's the entity schema.
I think the way I would see it is my input are the events. They build up the properties that I need in my read model. And I really only want to define the output and then see if my output maps to the properties that are in my input.
Yeah, so in this case, the request and response schema roles for that read model or are orthogonal to what you just described, which is what events feed into my read model. Those are separate concerns. So we can track which events feed a particular read model, regardless of the usage of that read model, if it's used by an automated job or whatever.
Yep.
But the data that is defined as this read model would be the set of data that is available to your automated job to do whatever it's trying to do. Maybe emit another command or something to either a system I control or maybe some foreign system. If I want to affect change outside of my world, I can build up this read model, have my little automated job. That automated job invokes a command, and maybe it's a foreign command on some foreign system like my payment gateway or whatever. And then if my payment gateway is good like Stripe, it'll call me back via webhook, and then I can emit an event, or I can just call it synchronously, get the response, and then emit my event from there. But the schema of the read model is simply what's available as the input to your automated job. If that answers your question.
So it's actually always an event that starts the whole show.
In this particular model, it is. In other systems, it's not. So it could be a read model, for example. Maybe I have a read model that some other team has built, and that represents point in time state for me. I query that read model. I show some data to the user on a screen, and then the user clicks a button because that user makes a decision, outside of the computers, up in wetware. That user makes a decision, invokes a command, that sends the command to my system, which then finally results in an event. So sometimes you start with a read model. Sometimes you start with an event. You almost never start with a command because that command's got to come from somewhere. But maybe you are a web service and you're getting commands from.
I was thinking about if we need to do the annual report, there is a command, an event coming in saying you should do your annual reporting, and then we could start the whole show, fits the reporting data and stuff like that.
Yeah, and often that will be an automation type interface. So that'll be like a gear interface, or even like a timer type interface that says, "Hey, every year on the January 31st,
Yeah, exactly.
send this command, which results in this event, which is report generated or whatever report is due or whatever that is." So, so now once we've defined, I'm going to skip all the way to my final model here. Once we've defined schemas for all of our commands, events, and read models, now we get to the really exciting part, which is I have the ability to generate Avro code. So I click this button. I get this pop-up here saying, yeah, do you want to save this zip archive? Great. save that. No, you'll have to let me know if you can see my.
We can't see where the pop-up came up, I'm guessing, because it's on a different window and you're sharing the specific screen, Bobby.
Yeah, that is probably true. Let me look here. Stop. Okay. Start again. Here we go. It's very exciting. You get to see my file browser. It's all very exciting. So I have this pizza delivery Avro zip. I can, expand that, extract those files. Yeah, thank you. And now I have pizza delivery Avro here at the top. So what I have here in this window is a AVPR file. That is an Avro protocol. What I have in my Avro protocol is my web services protocol that I just defined with my commands and read models. So that includes all of my commands and read models that I find here in my timeline. So this protocol actually does define a web service RPC definition, which we'll get to here in a moment. And I can use that to generate basically an entire application using something like gRPC. The other thing that I have generated here is a set of event schemas. These event schemas are organized per stream. So here we have two streams. We have an orders stream and a fulfillment stream. These represent independent causal narratives or bounded contexts. A lot of people in the DDD community love to call these bounded contexts. They map in your implementation to maybe a Kafka topic or a stream within Event Store DB or Redis streams or something like that. But it's a totally ordered, order preserving log of events. That's what a stream represents. So these lanes represent different streams. This orders stream comes from, we don't write to this. This is a read-only thing for us. We just notice when an order is placed, and that we incorporate that into our read model. Here in fulfillment, we do have write access to this fulfillment topic, and so we write this order status changed event to the fulfillment history or bounded context. So here in our generated code, we have a fulfillment stream. If there were multiple event types in that stream, we'd see all the different schemas associated with each of the events. So here we have the order status changed. This is an AVSC file or an Avro schema file. These are just JSON. So even though they have the extension AVSC or AVPR, these are just JSON documents. And they define an Avro schema. If you are using the Confluent stack or the Kafka open source stack, these schemas can be used by the Confluent schema registry. So if you have a schema registry in your stack, you just grab all of the event schemas associated with a particular stream, and then you navigate to that Kafka topic in your Confluent schema registry, and then you can just drop these JSON documents right in the schema registry. Now all apps that read and write from this particular stream will, if they configure the Confluent schema registry, have access to those schemas and be able to look those schemas up and deserialize the binary bits that are, or the binary bytes sitting on the Kafka topic. So that's what those are useful for. These are also useful for our implementation. We'll see this here in a few moments, but having these events allows us to do some event processing within our application, again, maybe in a Kafka Streams job or whatever. Being able to serialize and deserialize these events facilitates our event processing implementation. That's where I'm listening to events as they go by and building my read model from those things. So jumping back to this Avro protocol file, this is sort of the most interesting bit, and I'll pull up here IntelliJ. Switch screens here. Allow. So here, can you see IntelliJ?
I can see it.
Yes.
Okay, great.
It's a very tiny font, though.
It is very, very tiny. Let me see if I can do something about that.
Are you
Yeah,
in dark mode?
yeah, it's better.
Yes, and I'm in dark mode because I'm a geek. Sorry about that.
Oh, I prefer it on my eyes. I have.
I
too
do
many
as well.
I have too many floaters in my eyes, so anything on white background's just ugh.
Code. All right. So here we're looking at the Avro protocol file that we just generated. This is a pizza delivery protocol. So this was generated by Ono, and we've got these two messages defined here. We've got an orders to fulfill message, which is associated with a read model here. And we have a change order status, which is our command. These type definitions here come from the programmatic name that we gave to our schema. So if you go back to that schema panel in the app, that name and namespace gets converted from snake case or whatever into camel case here, or Pascal case in this case. But that's kind of where these namespaces and things came from. So we have two different messages here. We have our command, which is change order status, and we have our orders to fulfill, which is our read model. And we have a request and response type defined for each because we defined those schemas in our model. And then down below, we have a whole set of type definitions that support those top-level types that we need. So everything in Avro has to have its own type. Every kind of level on the nesting hierarchy has to have its own type. So these are very cumbersome to generate manually, like trying to handwrite these things. They're really a pain, often more trouble than they're worth. There's actually another intermediate representation that Avro supports called the IDL, which allows you to write in sort of a Java or C#-ish kind of interface definition language. Still pretty cumbersome, honestly. Like between the IDL and the JSON, like there's not very much time saved. What I'd rather have is a tool that generates it for me, so I don't have to author anything. So here, this protocol file is generated directly from our ONote event model. This application that I have here, this is nothing special. This is just a Micronaut Java application. Micronaut is a kind of a microservices framework or toolkit for Java. Well supported. It's got a lot of really great stuff built into it for building web services. Pretty straightforward stuff. The only bits that I changed is that I took out anything related to protocol buffers, which is gRPC's default serialization mechanism, and I put in Avro stuff. So here we have an Avro plugin or a Gradle plugin. We've got some dependencies on Avro gRPC and a few other things, but not too much there. All of this is in the example repo that I invited you all to clone. So you're free to peruse this code and see how this is different from just the Micronaut generated app template. There's very few differences here. It's just a matter of sort of swapping out protobufs for Avro. So then here in our application, very straightforward, right? I just have a main entry point and I can run this application. Great. In our configuration, we do a little bit of magic here to wire up. Oh, sorry. Let me backtrack a little here. So one thing that we do in our Gradle is by installing this Avro plugin. This will actually compile our Avro protocol, that JSON file that ONote generated. This will actually generate Java code. So from that protocol definition, we get a whole set of one interface that represents the protocol implementation, and then a whole bunch of concrete types that are smart enough to know how to serialize and deserialize themselves to and from Avro. And they have a Fluent builder pattern built in, so that I can very easily build these things within my application. So we compile this stuff. This build, of course, is going to take forever. There we go. So we're built, and then up here in our build file, we have this set of generated code here. It's really tiny. I wish I could make this side of it bigger. But here in the com example directory, we have pizza delivery. This is our Avro generated. You can see here that there's this annotation saying this is generated by Avro. This took our protocol definition and actually created a Java interface. So we have a change order status method that takes a mark order request class, type here, and then returns a Boolean, which is great. Same thing with orders to fulfill. I take in this request and I respond with this response type. So this is actually completely defined my interface definition language, my web services contract, which is really cool. So what I can do with that is here with a little bit of configuration magic, I create a gRPC service, a gRPC service definition here from Avro. So Avro supports gRPC. That's part of the open source distribution. So using these classes here, I can create a service definition from this class, and I pass it the implementation. So the implementation here is this pizza delivery service here that I'm injecting. Let's look at that definition. So this pizza delivery service here just implements my generated interface. And by doing that, I get kind of my whole implementation for free. So my IDE was actually able to, maybe we can actually watch the magic here. Why are you doing that? Gotta love live training, right? So my IDE now is smart enough to know, hey, you're not fully implementing this interface. So I can click implement methods. Yep, it invites me to implement the method. So now I've got code generation that actually generates the two methods that I need to override in order to have this web service live. I already have an implementation of that, as I showed you. There we go. So we have an implementation here of this interface. By wiring this up, I can actually run this application. I actually had it running, but oh, of course. When I commented things out, it decided to remove all my imports. So you see these things building down here, and sure enough, here's our Micronaut application. Can I make this bigger? Yeah, I can. Good. Down here on the bottom, I've got my console here. This is the Micronaut splash page, and here's my logging, just configured using regular Java logging stuff. Here I see, oh great, in my event processor, we actually have orders that have already arrived. Cool, and that's the orders that showed up here. Really neat. So that's kind of the implementation that's generated here. And now with a very few keystrokes going from ONote, generating the Avro, importing that Avro protocol, using my normal Java ecosystem build tooling, I build this application and I have a running implementation. This actually works. If I'm able to show, let's see here.
Your Micronaut program, was it ONote that generated that one?
Sorry, say that again.
What was it ONote that generated your Micronaut application?
No, I just generated a Micronaut application from Micronaut.io. They have a little application generator thingy. Yep. So I just downloaded the default template for Micronaut gRPC application. Downloaded that. That's in the example repo that's checked in, so you can see the code there. I just downloaded that, did a little bit of configuration to swap out protobufs for Avro, and then pulled my Avro file in and generated the whole implementation from my Avro. So all that's left to be done now is actually implement this business logic here, which I do. It's a precious little business logic, but that's what we do. So on change order status, our main job here is to validate that this is a reasonable request, and then write an event down to the log, because that's what you do in a command handler, is you just write an event to the event log. We saw that visually in our event model. So that's what we do. We grab this request, we say, hey, put onto this order status changed event log a new order status changed event. So I've got this builder. This class here, order status change, was generated via Avro. So it has this builder interface. I can set the status, I can set the order ID, build it. And that's what I write down to my event log. On the flip side of that, orders to fulfill, I get in a request. Again, we define this as an empty map, so it's not an especially useful request. But we grab from our order store. So this is where we store our materialized view. From our orders store, we grab all of the orders that we have available, all the orders that are pending fulfillment, and then we return those as a part of the response. So I can actually do this. The other side of this application that I've built, we actually do have a UI. It's written in JavaFX using Clojure. So using the same exact Avro code, I generated a client on the Clojure side as well as the server on the Java side. So I have the same Avro protocol, and I can generate the same set of Java classes from that from the single interface that I generate, that pizza delivery interface. I can instantiate both web services, as you see here in the code that's being shown, as well as clients, which I have in my JavaFX app, which I've implemented in Clojure. So over here, if you look down here on the lower right, you can see our logging. I'm going to instantiate a client, and I'm going to call the orders to fulfill web service method. And you see here, sure enough, we got the orders to fulfill with an empty request. So that's how that worked. If I can show you Clojure, will this work for me? Yeah, there we go. So I'm switching over from IntelliJ, which is my Java IDE, over to Emacs, which is my Clojure IDE, and I can print out the response that I just got back. Sure enough, it's a map with orders and then a list of order objects that I've gotten back here. So I've got a customer ID, a delivery type order, here's the status of that particular order, etc. Good? Great. Actually, I haven't prepped for this, but I'm going to try it. We can take one of these order IDs and we can send back a change order. This may or may not work. This is me ad-libbing. Let's see. Great. Value up. That's how you do that in Java. Okay. Great. So if I grab this UUID here, or sorry, rather the order ID. Okay, I will say, again, I have no idea whether this will work. Let's see. Oh, it did. Oh. Okay, hey, that worked. Yep, sure enough, here on the other side, if I can switch my screens. So here on the other side, on the server side, I received a change order status request with a particular order ID. That's the one that I sent over with the new status en route. And then my event processor picked up the fact that I had written this event down in my command handler and then actually processed that order status changed and updated my read model. Now, if I check my orders to fulfill, yep, sure enough, one of, I'm going to switch you back and forth now. Some screens. So now the order whose ID I just grabbed and sent in my command, I just re-requested that, and sure enough, its status is now en route. So we've gotten kind of one full round trip of fetching the initial read model on my client, grabbing a UUID, setting the status of that particular order to the new status, and then re-grabbing that read model, and sure enough, it's been updated. So that whole implementation here works. There's one more piece of this implementation that I'll show you very briefly, and that is the event processing. Right now, this is like cheap and dirty event processing. We're not using Kafka or Event Store DB or anything like that. We're just using some in-memory constructs rather than having you all during this training go to the pain of like configuring Kafka topics or configuring, foreign services or whatever. I just implemented a few very simple in-memory constructs. So we've got a
yeah, I'm trying to do some examples, Bobby, with IndexedDB and having everything in the browser for some learning examples.
Yep.
And it's just, simple JavaScript, but, you can really experiment even in just the console in your browser, which would be really cool. So we got to make more learning materials like that, just so people can
absolutely
very easily understand how this code generation is different than what it was, from class diagrams and things we had years ago.
Yeah, and most frameworks really want to tie you into a data persistence layer really quickly, and a lot of the code is really tied to that data persistence layer. Here, I'm just saying, hey, I just want to have an event log that is just a blocking queue, a Java linked blocking queue. That's as good an event log as any when you're dealing with in-memory stuff. I want to have a read model store that is just a concurrent hash map. And I can put stuff in my concurrent hash map, and then I can take stuff out of my concurrent hash map. So this event processor proceeds on that basis. Basically, when I initialize the bean here in a separate thread, I say, hey, every time we get a new event on the processing orders log, or excuse me, on the orders event log, take it and then add it to the store. So we grab the order, we put the order in the read model store. Every time we get an order status changed event on the order status changed event log, it's really the fulfillment event log. We look up the particular order in question, and then we change its status to the proper status. So here we have the full command to event that happens in your command processor. That's where we write the event to the log. From event to read model, that's here in our event handler, our event processor that incorporates those events and mutates the read model as necessary. And then we can query that read model back out from our client and see that the changes have taken effect. That was a lot of stuff. I went really fast. I'm sure you have questions. Please, let's have me stop talking and have you all talk a little bit.
You've stunned everyone.
Speechless.
Yeah, it's from my perspective, it's really nice to start to adapt this for multiple different languages, etc. Because we're all doing the same thing, right? I mean, how many different ways can you slice up pizza ordering? Pardon the pun. So, it's the same information. Someone's typing in what they want, their name, that's all characters. And it still amazes me how fragmented information systems are in terms of what talent needs to be there to get the exact same thing done. It's crazy to me. So I really look forward to, just like there's many clients being written for Event Store and Kafka endpoints in different languages, I see the same thing for this, that there'll be many different generation endpoints for whatever someone's comfortable with, whatever infrastructure they already have to support it. And I also look forward to multiples of them, because these, like I said, these workflows can be stitched together. You have a common thread here for state in terms of events are kind of a good way to abstract, even if you don't do event sourcing, a good way to abstract how that's a contract when you have to move over from one implementation to another. It makes it really, really clear what needs to be done to make those different worlds work. And that's where you start to make really, again, what someone said, the together motivation, like together we're a lot better. And so building those bridges is helped by all these things. Yeah.
So really quick, Adam, to your point exactly, the way that we're selling this product, right? Because we're a business, we're very interested in building the right product to help the company, to help the community, make this a mainstream way of developing things. The way that we're marketing this is we've got this ONode Essential tier, $5 a month, that gets you access to all the goodies, which is basically Figma embeds, schemas, etc. But it also gives you access to power-ups, which we have below. And we have a redesign of this page that's coming that'll make this clearer. But the power-ups down here below are really where the magic happens. So the only power-up we have right now is what I just showed you, this Avro CodeGen power-up. But one of the next ones that we know we plan to make is a GraphQL CodeGen one. So it's the same exact thing. We walk the schemas and the data flow connections, and we're able to create schemas and definitions for your mutations, which are your commands, schemas for your queries, which are your read models, and even subscriptions.
That one's awesome for GraphQL because they have a lot of clients that are using it now.
Yep. So GraphQL's one. Async API, I think, is going to be a gateway into automating the event processing layer. So right now, the Automagic parts was the web services definition, right? We had the commands, the read models, all implemented basically as methods that is automatically wired up by gRPC, and everything just works. So that part of it's really smooth right now, that kind of timeline of commands and read models. But the whole kind of event processing layer, how do I react to events and build up my read models and execute side effects and all that kind of stuff. Async API is a really great way of describing that. So being able to generate async API allows us to reach a lot of other ecosystems, React, ReactiveX, whatever it is, reactive JavaScript, or Kafka Streams, or KSQL, or serverless stuff, where we're automating the creation of JavaScript functions for you and allowing you to deploy those as Google Cloud Functions or Lambdas or whatever. So there's a lot of cool stuff that we have in here that we're looking forward to doing. The first kind of iteration of this to support Avro enabled us to get schemas live, all of that stuff. But really, the future is much bigger, right? It's much bigger than just Avro and gRPC. We want to get to the point where we can generate code throughout the stack and automate the implementation of this as much as possible. But we want to do it in a way that's respectful of developers, rather than a lot of these kind of low-code things try to end run around the developers. But
it needs to be a base code where you can augment easily, right? So
exactly. So it's generating representations that developers are comfortable with and that fit into your CI/CD patterns and generate things that you can actually use and interest.
And that's what I like about this, because it's already what we're doing kind of manually anyway. We have because event modeling promotes a high level of cadence, that you're just doing the same thing over and over again. Once you have your infrastructure in place and your UI patterns in place, you're really doing the same thing over and over again, and that's where I think a lot of the automation can help. So I see this as an extension of what we do anyway. Once we find a real good groove and cadence to exist in a certain set of frameworks, etc. So the more that we can do with the same approach, but not have to just sit at the keyboard for as long, because we know what we want at the end. We're really our minds are already there of what we want the next step to be, and so shortening that timeline is really good. I see this as an extension of what we get in IDEs. The fact that it's a paid product is great, because we get that anyway from we buy IDEs. And the JetBrains suite is amazing. I don't need to really do anything else for programming because of the amount of features that they pack. And they listen to what that IntelliSense is supposed to do, or the refactoring is supposed to do. It does a lot of stuff that I don't have to think about anymore. And I know that I would do that manually over 20 minutes, but it does it for me in one shortcut, which is great. And so by extension, the same thing from a higher level, we can still attain that similar productivity. And so do you spend thousands of dollars a day for developers to slave away at for 2 weeks on something that can be done in a minute of generating the code? The answer is pretty simple, right? You get way further ahead, and these are just extensions of what we naturally want to do. At least we as an organization want to do, and I think others are trying to find these ways to get that cadence and that predictability. So then you really start to lower the costs.
So sorry to interrupt, Adam. We have hit time. If you have to drop, great. I have some more time to answer a few questions. Jason Graber asked a couple of good questions.
Jason's here. I didn't know he was here. My goodness.
He made a good recommendation about IntelliJ presenter mode too, which I didn't know that IntelliJ had a presenter mode. Yes, Jason, we already are able to generate JSON schema from the native schema format that we store as a part of the model. So we will be releasing that functionality soon. So JSON schema will certainly be another target. That's relatively easy to do, and there's actually some really cool libraries for generating, say, React forms from a JSON schema. So that's another target that we're interested in hitting relatively soon, and we get that for free just by using the schema library and format that we've chosen. So JSON schema is easy for us. Yeah, folks asked about async API. I think we answered that. Can the event schema drift from the read model schema? That's a very good question. Adam answered it. Yeah, they're different almost all the time. Really, there's a formal relationship between events and the read models that they feed. So for a read model, there's what's called a reducing function. It's the same function that you use for reduce, where you have the aggregate as your first argument, and then the next element in the sequence that you're processing. So really, you're just taking an event and incorporating it into the read model. The schemas are event schema for the event that you're observing go by, and the aggregate schema is your read model schema. So that's the actual shape of the data that you're storing and then presenting to your user. So yes, they are different, but they're related in a specific functional programming formalistic way. Like we know the function signatures are the types. If you're into ML languages, the types of these functions that allow you to transduce an infinite sequence of events and into a read model. It's an aggregate on that. Anders asked a really important question. Can customers make their own code generators? Yes. All of this is built on an open data standard. So if you export the JSON, you can see all the stuff that we see for the most part of the models. We're continuing to evolve that data format. So you'll see beta tagged at the end of that versioning. We do version that export format, and as we add more capabilities, as we really settle into our final kind of schema data format, we will be putting that at 1.0 and then releasing it as open source. So we'll have a specification. Adam's behind this. We're super excited to have him and his team and their input, but we'll have a data specification that defines, here's what an event model is, right? Here's the commands, events, read models, here's the placements, here's the schemas, here's how they all interrelate, and so forth. So we will have that released as an open data specification.
That's really important because we really want to evolve the entire sort of industry going forward to have solutions that are not tied to a specific stack. It's a lot of times, especially when we look at your tax dollars being spent in places, they're going to companies that really want that lock-in. So open standards is something that I'm really behind, and any kind of commercial interests can make money off of them. That's fine. That's good. But the data needs to have portability, longevity, and ownership. And I think those key things need to be there for the success of all our customers, and we wouldn't ever want to do something where we act against them.
Yeah, exactly.
I think there's one thing more to that question, because what Bobby showed with that schema generator on the UI, you answered some questions and could look up stuff and like that. So somehow that generator or that definition application is part of the editor.
Yes. So we've built basically UI to allow you to define that format. But the format itself, you can author just using a text editor.
Yeah, we actually had a discussion about this a couple of days ago, Bobby and I, and we kind of looked at that UI as something that's needed because you need to have some of these abstractions. Otherwise, it's a little bit, you might as well be typing code at some point. We're looking at ways to remove the IDs so that you're just picking from something that's already defined somewhere else. You're not staring at a wall of IDs that you have to follow through the entire document to find what it actually is. It has to be more human friendly. Yes, that's how we make references to other parts, but when we're interacting with it, it needs to be more pleasing to the eye and give you the information as to what it is that's sitting at that particular node at that point.
And we do use an open source library as the format for those schemas. So that library for engaging with those schemas and doing interesting things with them is available. So you can read our format, use along with the open data format. I think we will have some SDKs and other things that allow you to reach and do interesting things with those models from different programming languages, and that will include that schema format and doing interesting things with those schema.
So it is Clojure you are making the generators in?
Yes. So we program in Clojure. It is a Clojure library called Molly that we use as our schema format.
Okay.
Yeah.
Okay, we're about 7 minutes over. We still have a lot of people on the line. Thank you for sticking with us. We're available. My last plug will be, we are looking for really excellent software teams to do free pilot projects. So if anything that you saw on today's training is interesting to you, we would love to do a pilot with your company. So, it'll be free, no cost to your company. We'll come in, we'll help you build the model, we'll help you do the data modeling and so forth. We'll help you generate the code, implement the code, get the service into a production-like environment. That will be kind of the scope of the engagement. So we'd love to hear from you. If you're interested, please reach out to me, bobby@onote.com. Be happy to hear from you. Thank you.
Thank you, everyone. See you on Slack as well in the regular meetups, etc.
Yes.
Bye, everyone.